This is lecture 5, solving linear programs problems using computers for IE 3340 operation research. So in this lecture, we're going to learn how to solve linear programs using the computer, specifically using Microsoft Excel. Excel provides us with a solver add-in that can be used to formulate and to solve linear programs using the simplex method. So the agenda for this lecture is the following. We're going to start with the introduction. Then I'm going to explain how to setting up the spreadsheet. And we're going to use the Yapetos Inc. problem that we discussed in class to go through the lecture and to implement the model in Excel and also finding a solution. So the last thing we're going to do is to find a solution using the Excel add-in solver. So the learning objectives for this lecture is to use Excel solver to solve linear programming models. The introduction. Excel has the capability to solve linear programming problems. In this lecture, we show how to use the Excel solver to find the optimal solution to a linear programming problem. The key to solving an LP on a spreadsheet is to set up a spreadsheet that tracks everything of interest. For example, the costs or profits, the resources, and so on. So let's talk about setting up the spreadsheet. We want to identify the cells of interest that can be varied. These are called the changing cells. In a linear program, those are represented by the decision variables. So when you formulate the decision variables for your linear program, you know those decision variables are going to change. Let's say we start them with 0, 0, or with value 0. When we set up the constraints and we solve the problem, we know the values for the decision variables are changing. So in Excel and in this implementation in Excel, we're gonna use or we're gonna call these changing cells the cells that are representing our decision variables. Then we're gonna identify the cells that contains your objective function, and that's what we're gonna call the target cell. So we're gonna program the objective function in a specific cell. That is our target cell, which is our objective function. And third, we're gonna identify the constraints and tell the solver finally tell the solver to solve the problem based on those constraints. At this point, the optimal solution will be placed in the spreadsheet. So let's start with using the Excel solver to solve the Yapetos Inc. problem. As you remember from our previous lecture, in this problem, we have a manufacturer that has two types of products. One is the soldiers that sell for $27 and uses $10 worth of raw materials. Increase Yapetos variable cost labor overhead cost by $14 and requires 2 hours of finishing labor and requires 1 hour of carpentry labor. And then the second product are the trains. So each train built sell for $21 and uses, I'm sorry, that's a typo, $9 worth of raw materials, increases Yapetos variable labor overhead cost by $10 and requires 1 hour of finishing labor and requires 1 hour of carpentry labor. Each week, Yapeto can obtain all needed raw material, but only has 100 finishing hours and 80 carpentry hours. Also, the demand for trains is unlimited, but at most 40 soldiers are bought each week. In this problem, we want to maximize the weekly profit, which is the difference between revenues and expenses. So the first part is to formulate a mathematical model of this problem that can be used, that can maximize the weekly profit. So this is a formulation for this problem. We have the objective function. After we know the revenue, we know the cost, so we look at the difference and that's the profit. So for soldiers, we have $3, and for trains, we have $2. So 3x1 plus 2x2 is our objective function. And then we have 3 constraints: the finishing constraint, the carpentry constraint, and the constraint on demand for soldiers. And finally, we have 2 sign restrictions constraints. X1 has to be greater or equal to 0. X2 has to be greater or equal to 0. We learned how to solve this problem using the graphical method. And when we solved the problem in class, we found that the optimal solution was on x1 equals 20, x2 equals 60, and the objective function value was $180. The reason I'm showing the optimal solution using the graphical method is I want you to see that the solution is going to match after we solve the same problem using the Excel. So let's see how can we get started with the implementation in Excel. So I'm going to show here. I'm going to open the Excel file on this side. So we're going to begin by creating the a table with the problem information, headings for each product type, resource availability for each product type, and demand for each product type. So the first thing I do when I set up my problem in Excel is to create this table of information that includes all the details from the problem, because I'm going to be referring back to those numbers when I'm setting up the constraints and also the objective function. So I set up the data at the top. We have this information, the selling price for each one of the products. So soldiers 27, trains 21, raw materials 14 and 10, variable cost 10 and 9. And then we also have the requirements in terms of finishing labor 2 and 1, and carpentry labor 1 and 1. So if you are familiar with Excel, then you can program the formulas using those parameters. The good thing about using or setting up a table like this is, like in the future, if you have, for example, if the selling price changes, you can easily modify the table, and that will be also modifying your implementation of the linear program in Excel. And then show what that means in a second. So setting up the data is important. And then, as I mentioned in the lecture, we have a couple of decision variables. These are our changing cells. So you have to select a cell for each one of your decision variables. So in this case, we only have 2 decision variables, x1 and x2. But if you have 10 or you have 20, you have to set up one cell that will be used to represent that decision variable. So in this case, only 2 decision variables. So I have one cell. This cell is representing x1. This cell is representing x2. And we also have a cell for our objective function. That's what we call the target cell. So that cell is going to be this one. And then for each one of the constraints, I have the information of the right-hand side. So what's missing is this piece right here, which is a formula that is going to represent the left-hand side of the constraint, of each one of the constraints. Okay, so let's go back to the PowerPoint. Trying to see if I can. Okay. So let's set up the solver. So first, I want to set up my objective function, right? And remember, the objective function is stated in terms of the profit. So we have some information here, both for soldiers and for trains. So in the slide, you can find the formula for the objective function, but I'm going to guide you through that process now. So the objective function, we have two products, and for each product, we have a revenue and a cost associated to it, right? So for the first product, I'm going to use the information from the table. So I'm going to set up the equation, right? In Excel, to set up an equation, you have to first put the equal sign in order for Excel to recognize that that is an equation. So equal is just to get started with the constraint, and then I'm going to refer to the sales for the soldiers. So we have a revenue of 27, and then I had to subtract the cost, the raw material cost and the variable cost. Okay, so all that has to be multiplied by your decision variable. In this case, the decision variable is X1. So X1 is represented by this cell. So it's multiplied by that. And that's going to be the first piece of the objective function. If you solve B2 minus B3 minus B4, that should be equal to 3. And you're multiplying that times B9, which is X1. So you have the first piece of that objective function, 3x1. Now I'm going to add the second part. So I have the train, the selling price is 21 minus 10 minus 9. All that multiplied by the cell representing the decision variable, X2. And then I can close the parenthesis. And that's going to be my objective function. Okay, so if I hit enter, this should be equal to 0 because there's no values for the decision variables yet. But for instance, if I do 1 here, this should change to 3 because it's 3 times 1 or 3 times x1. X1 is represented by 1, so this should be equal to 3. I can do the same test here. If I do 1, then this should be equal to 2 because it's 2 times 1. 2 times 1 is 2. Okay, so that objective function is working. So we have the objective function, and you can refer back to the PowerPoint slides. You see here at the bottom, we have the equation that I just typed in to the objective function. So now I want to set up the constraints. In the same way, I'm going to set up an equation for the left-hand side of the constraint. So for the first constraint, we have the finishing constraint. And this one is equal to the hours for finishing hours that takes each one of the product times the decision variable, right? So in this case, for the finishing constraint, we have the finishing labor hours for the soldiers multiplied by the decision variable, X1. So this is 2x1 plus 1 times the decision variable for x2. And that's going to be the left-hand side for this problem, for this constraint. In the same way, I can go to the next one. So this one is on the carpentry constraint. So I have the carpentry labor hours here. So I'm going to use those parameters. So it's 1 times x1 plus this times x2. And the last constraint is the demand for soldiers that has to be less than or equal to 40. So this is just x1. So I'm going to click on that cell, B9. X1 is less than or equal to 40. Okay, so there's no formulas needed for the right-hand side. These are just numbers that I enter. You'll see how this come together in a second when we set up the solver add-in. Okay, so the next thing is to look for the data tab and select the solver. So if the solver is not available, you will have to install the analysis toolpack and the solver add-in. So let's see. If I go to data here in Excel, I have the solver installed in my Excel. But if you don't, you can go here to File, Options, click Add-ins, and you'll find the analysis toolpack. You can go and do Go and select the solver. So the solver add-in, you select that one, and then you click OK. So now you should see the solver in the data tab. Okay, so that's what I'm showing here on the slides. If you look at slide 20, I'm showing you how to get the analysis toolpack and how to set up the solvers add-in. So you go to options, add-ins, you select the analysis toolpack, then you click go. And after you click go, you select the solver and then click OK. Okay, so let me show you that one more time. If your solver add-in is not showing, you go here, you go to File, you select Options, you click on Add-ins, you select the Analysis Toolpack, and then you click Go. You will see this window, you will select the solver add-in, and then click OK. And now if you go to Data, you should see the solver here. So now that we have the solver, we can click here, and you will see this window. Here's where we're going to set up our model. Okay, so we're going to start with the set objective at the top. And we're going to find, I'm going to show you that again. So if you click here, you can do this arrow, click this arrow, and you can go select the objective function cell. In this case, it's this cell, so I'm selecting B11, and then I hit enter. That's the first piece, set the objective. In our case, the cell that is representing the objective function is B11. And then you have to select whether you are maximizing or minimizing. So in our case, we are maximizing. The next thing is to select the changing variables. So remember, the changing variables are the decision variables. So I'm going to click here, and I'm going to select both of them like simultaneously, and then click enter. And the next thing is to add the constraints. So I'm going to add each constraint one by one. So I'm going to start with the first constraint. So this is the cell reference for the left side, B14. This is a less than or equal constraint, right? So I'm going to make this less than or equal to, and the right-hand side of the constraint is 100. Since I have multiple constraints, I'm going to add this one, and then I'm going to look for the next one. So the right-hand side for the second constraint is this one. This is also a less than or equal constraint, and the right-hand side is 80. And then I'm gonna add that one too. And then I have constraint number 3, less than or equal to 40. So this is the right-hand side. And since this is my last constraint, I can hit OK. After hitting OK, then you'll see the setup for your model. You have the objective function, you have the changing variables, and you have the constraints. The solver, you remember the non-negative constraints for the decision variables. We want to make x1 greater or equal to 0, x2 greater or equal to 0. So you can make that automatically in the solver by clicking here, make an unconstrained variables non-negative. So by selecting this option, you're making x1 greater or equal to 0, x2 greater or equal to 0. The next thing here is to select the solving method. So we can select the simplex method. And at this point, everything should be set. So the last piece is just to solve the problem. And after you click, if the model finds a solution, it will tell you in this screen. So solver found a solution. All constraints and optimality conditions are satisfied. So we want to keep the solution and click OK. Now, if you go to the Excel table, you'll see that the changing variables are now filled with the optimal solution 20 and 60 and the objective function value, which is 180. That solution matches our solution right here. So as you can see, we can use the Excel to solve LP models. So everything that I just did is represented in these slides. So you can refer back to the slide if you need to. So I show you piece by piece how everything is set up for the constraints and the objective function. Also remember to set up the solving method as simplex, because this is the solving algorithm that we want to use for linear programs. And remember to solve. And at the end, we keep the solver solution, we hit OK, and we get the solution 180 with decision variables x1 20, x2 60. And that concludes this lecture on how to use Excel to solve linear programs. So Excel provides us with the solver add-in, which has the simplex linear programming algorithm implemented, and we can use the simplex method and solve linear programs using Excel by implementing the algorithm, the simplex algorithm, or the simplex method in Excel. So in this lecture, we cover how to set up the spreadsheet. We also solved one of the problems that we discussed in class, and we found the solutions using the solution for the linear program using the solver add-in, which implements the simplex method.